Welcome back. In this video, we'll be talking about some very special functions, and we'll start with polynomials, the exponential function, logarithmic functions. I'm not going to give you actual definitions of these functions. I'm just interested in collecting the most important facts that you want to know about these functions going forward. Okay, so this is again part of the introduction. And this is called polynomials, exponential function, and logarithm. So let's start with the polynomials. Often encounter polynomials, and we have actually already seen some. Those polynomials are basically made up of what is called a monomial. A very simple case. And what you have is you need to give an exponent. So for a given exponent, let's call that n, that's natural number, including 0, might be the case. And a constant, call that alpha. That can be any real number. The function t that maps from R to R and is defined as p of x equals alpha times x to the n. That is called a monomial. And the number n is called the degree of that monomial. And now if you combine several monomials together by just summing them, what you get is a so-called polynomial. Okay? So a function, let's call it f. Again, mapping from R to R is called polynomial if it is a sum of monomials. And you usually collect those such that the degree of each monomial in the sum is different. So you collect the coefficients for the same degrees together, meaning you have something like f of x equals some constants alpha 0 plus alpha 1x plus alpha 2x squared, and so on, up to alpha n x to the n. Now, the highest monomial degree that you incur in a polynomial is called the degree of that monomial. And the coefficient that goes with it is called the polynomial's leading coefficient. Highest monomial degree in f is called the degree of f. Its coefficient is called the leading coefficient of f. Okay, and that's pretty much all you need to know about polynomials for now. Now, if we go in one step further, you'll notice the variable in this polynomial expression is the x. The powers always constant. Might be different powers, but they're always constant for each x. Of course, you could also do this the other way around, but have a constant base and then raise that to some variable power. So have the x in the exponent. And that is a different class of functions. That's called an exponential function. So say for a given so-called base, we write this as b, can basically be any real number. The function f of x equals b to the power of x. That is called an exponential function. Basically, what you need to know about exponential functions is a number of rules how you can do computations with those. So we'll just list some of those rules. First, if you raise a base to the power of 0, the result is 1. There is one possible exception to that, and that is 0 to the power of 0. We won't discuss this in more detail, but basically you're free to define this as either 0 or 1, whatever fits your case best. Yeah? In some cases, 0 seems a natural choice. In other cases, 1 seems a natural choice. We discuss this whenever the problem arises. Yeah, but in most cases, b to the power of 0 is 1. Then, of course, b to the power of 1 is just b itself. And if you combine different terms like b to the power of x times b to the power of y, this is the same as b to the power of x, y. And then there is the neat notation b to the power of minus x. Yeah, change the sign of that. That's the same thing as 1 divided by b to the power of x. And of course, for this to work, b better not be so. And finally, you can also raise an exponential function to a power. So b to the x to the y, something like this. And this is the same thing as b to the x times y. So these are the rules for dealing with exponential functions that you should be aware of. And finally, there's an inverse to an exponential function that we also will encounter frequently. And that is called the logarithm. Inverse of an exponential function with base b is called the logarithm to base b. And again, a few rules apply. Of course, by definition, if you take the logarithm of b to the x, then you get x. And the same applies if you take b to the power of log bx, like this. Yeah? Then from the exponential function rules, what you get is here. So the logarithm of 1 is always 0. And of course, the logarithm of b to base b is always 1. And the other rules for taking exponentials also transfer to the inverse, to the logarithm. First one is if you take the logarithm of a product, x times y, that's the same thing as taking the individual logarithms and summing them up. I'm not writing the base here because that applies to every possible base. Okay, of course, this is only defined for positive inputs, as the whole logarithm is only defined for positive inputs. Also, log over fraction, like x over y, that's the same thing as log x plus log 1 over y, which is log x plus log of y to the power of minus 1. And we'll get to that rule soon. You can take those powers out of the logarithm. So what happens here is that's the same thing as log x plus, we take out the minus 1, and then we have minus 1 times log y. So this is, in short, log x minus log y. And that's only a very special case of the following general rule, where the logarithm of b to the power of x is the same thing as x times the logarithm of b. Now, as far as the base is concerned, if you have a logarithm to a certain base, like log x to base b, then you can convert this to a logarithm of pretty much any base. By this rule here, that is the same thing as the logarithm of x over the logarithm of b, where you can use any base on the right-hand side. It just needs to be the same. I'll just mention there's one very special base. We won't discuss at this point why this is so special, but we'll get to know it later, and we'll see it has very special properties, and that is Euler's number. So let's just make a note of that. The logarithm with base e, and that e is known as Euler's number. And is approximately something like 2.71 and so on. I'm not going into the details here. We'll talk about Euler's number later on some more. That logarithm has a special name because it occurs so often that it's called the natural log. We'll learn more about why this is an appropriate name later on when we get to this in a little more detail. But just so you know, that logarithm is called natural logarithm. And it has a special notation. It's abbreviated as ln of x. Ln of x is the same as logarithm of x to base. Okay, I'm not going to introduce abbreviations for any other logarithms. Mostly what we do about these holds for any base you want to choose. We usually work with the natural logarithm for several reasons, but you can also convert this to any base you like. Okay, that concludes the introduction into polynomials, exponential function, and logarithmic functions. So I'll see you in one of the upcoming videos.